It's quite closely coupled. Okay. Afternoon, I'm Darren Storer, G7LWT, and with me is Jean-Pierre, F6DZP, and we have a presentation for you about a software analyzer. Started off as a software analyzer, turned into an awful lot of other very good things along the way. I should issue a warning at this stage that the last time Jean-Pierre gave this presentation in Switzerland, it took 3.5 hours. Good news is, I'm between you and Jean-Pierre. So I took 30 pages of A4 material and reformatted it, and you'll see some quite small fonts, a little bit smaller than we'd normally use for PowerPoint work, but hopefully you can bear with it. The byproduct of all of this is that a lot of the really good technical detail will most likely end up in a BATC article over 2 or 3 editions. So there's some good technical material to follow up in the future. So over to Jean-Pierre, who will talk to us about Tutioune.
Yes. Okay. Hello to all of you. My English is not very good, but I'm very glad to be here today. About Tutioune, when I started to work with DATV 3 or 4 years ago, I was very disappointed by the use of set-top box. With a set-top box, you have only level and quality and never the same signification from one box to another. So, for me, it was very bad tools. I thought it's impossible to give a report with this kind of equipment. So I tried to find information about how equipment can receive a DVB-S modulation, and you can search on the net. It's very, very difficult to find something, and I can say you will find very, very few things or nothing. So I've started to look what kind of chip we can find in set-top boxes, and how can we develop a software for ham radio. The first way I found is to use a Dreambox. A Dreambox is a box a little intelligent with Linux inside, but it was a problem for me. I don't know anything about the Dreambox, about Linux. And I am not a computer developer. So I look at tools that exist on PC. And on PC, we can find USB cards and PCI cards that you can plug in your PC, and you can find some software, but not software for ham radio. Oui, the remote control. Okay. No, c'est ça. Okay. So the first step was to understand how can work a QPSK demodulator. And we can see with this first diagram, this is essentially the reverse of the transmission system. You have firstly, where is the button? This? The demodulation, the first demodulation, and after you will find the Viterbi decoder, you will find the Reed-Solomon decoder, and after the transpose stream is generated to the second part. This first part is made by a first part in the set-top box or in a PC, in the PC card only. And the second part is demultiplexing, demux, I don't know exactly the word in English sometimes, and decoding by the software or the firmware inside a box. I try to understand where can we make measure. There are different parts from the signal, the RF signal, to the video on the monitor and the audio. The first part, you have a RF signal. We will see we can measure the level, the CNR. At the second part, you have the data. The IQ will be digitized very quickly. We will see that in the receiver, the analog part is very short. So IQ is digitized and all is processed, digital processing. We can measure some specific information we call MER, Weber, V-bar. On the transport stream, we have other kind of measure we can do about the PCR errors, PCR jitters. We need specific software for that. And when you have the elementary stream, you can also make some measure about the compressing quality in MPEG-2 or MPEG-2 or H.264. And the last part is just to decode and to render. So for ham radio, we have to change our mind. We are not in an analog with an analog equipment. We can say B5, B4, or P5, P4 to give a report. And we must find what can we check, what can we say to the other OM who is transmitting. This is an example of PCI card I used for my software. You can see there is very little chip on it, very few chip. You have the zero tuner, the NIM tuner avec inside, excuse me, sometimes I speak in French, with inside only one chip, which is the zero tuner. We will see how works the zero tuner, but the zero tuner just take the RF frequency we need and output the IQ to the demodulator. The IQ signal is in analog, and after all will be digital. So you have the zero tuner, the demodulator. This is the STB899 from ST Microelectronics. And this is just the multimedia interface, the SAA7146. We can find this chip on many cards, not for DVB, for video acquisition and so on. It's an interface for the PCI bus. We have also another chip a voltage generator for the LNB, and a little chip for the remote control when you want to use the remote control to change the channel on your PC. So this is the diagram. The zero tuner synthesizer, QPSK demodulator STB0899, the chip interface, and the PC. All data are not the transport stream, but all command to the demodulator, to the zero tuner, to the LNB P21 are made by E2C. So I had to find a driver that allow me to discuss, to send what I want to the demodulator. There is also an E2C repeater to send your command to the zero tuner. Zero tuner, you will see this is the only port inside the chip. We can see RF in. We have an AGC signal from the QPSK demodulator. We will see later. We have the E2C instructions are coming to set the VCO, parallel VCO on the good frequency. The frequency is 2 or 3 times the frequency asked. It's divided after by 2 or 4. And we have dephased the signal to obtain I and Q signal. We have low pass boundaries, filter boundaries, that we can set up from 5 to 36 megahertz. It's a shame for me if I say this morning, if I could have a bandwidth lower, I could use the chip to create a spectrum analyzer. But we can have many information. So the step is about 27 kilohertz. So we can have any frequency we want. The zero tuner can be set only to frequency multiple of 26 and so on kilohertz. This is important because firstly in the QPSK demodulator we will see something special, a magic tool for me that allow to correct this problem. Because if you have this frequency and you want to set to 1255000 megahertz, this is not an exact multiple. So you never can set the receiver exactly to the bit, to the 0 bit. And so your IQ information will be turning. And with my software, we will see them turning. Bon, AGC range, 70 dB typic, and baseband gain can be set to 17 dB maximum. How? We will see with Tutioune, we will see this diagram. This diagram is perhaps difficult to read. Inside the STB demodulator, the STB 0899, firstly, IQ are digitized. This is the only analog part of the chip, inside the chip. IQ is digitized with A-bit, ADC. Many QPSK demodulator only use 6-bit, but this use 8-bit. You have the clock generation, and after we go inside the QPSK demodulator to firstly integrate the signal to find the value for the AGC that go back to the 0 demodulator. And inside the chip, we will find different PLL to recover the carrier frequency, the exact carrier frequency, and a second PLL to recover the IQ frequency, the symbol rate frequency. There are two timing to lock. And you have inside this chip an echo constellator, an equalizer, a demapper, and you will find here all to correct all VTRB decoder for VTRB correction, the Reed-Solomon decoder, and if all is well done, you can have the transport stream at the output. Just in mind, to have simple explanation, I go back to QPSK. And just for our heads, a simple view, perhaps, but in my mind, I say that when I have a QPSK modulation, I have data, lot of bits, 0, 1, 0, 1, 1, 0, and when I receive them, they are grouped by symbol. Each IQ data is a symbol, and it corresponds to a coordinate of a point. If the point is in this quadrant, it is 1, 1. In this quadrant, it's 0, 1. In this, 0, 0. And this, 1, 0. And for that, we will see that to look permanently to the constellation, to a tool that can show us these points. During your reception, you are receiving something and you see all the time, in real time, you can see the constellation. And if you have this tool, when you turn your antenna, when you give more power, you will see in real time the effect. And sometimes giving more power give not sometimes more beautiful constellation. I have looked at a book the ETSC technical report. You can download it. And there are specific chapters about DVB-S and DVB-S measuring. And there is conclusion about what is the best value for me, is the MER. We can, firstly, measure the RF level. The RF level, you know it. It's we have the habits. We are in an analog world. RF level, you can have it in dBm, you can have it with the spectrum analyzer, and you can have it with my software, Tutioune. E and Q levels are more difficult to obtain because it's difficult to find equipment that allow directly to E and Q signal, analog signals. But when IQ are digitized, the STB899 can give you information about IQ. So I have add a little oscilloscope to see IQ. There is a color for I and a color for Q. And this can help when you want to set up your DigiLight, your rig, using the oscilloscope and using other information about EQ. If I want to measure the signal to noise, there is a value. I know this value. This is the CNR. The CNR is made on the RF signal. It's an analog information. We can use a spectrum analyzer if we have one, and it's not very cheap. We can make measure on analog SNR, analog EQ, on digital SNR, and we can also make measure about the MER and the EVM. We will see them now. CNR, you can have them with the spectrum analyzer, the difference between the top and the noise. I think we can go on. The analog SNR on EQ, it's the same kind of measure, but you can do it because you don't have IQ signals. I just can say that IQ, the amplitude is between 0 and 1 volt, or 0 and 2 volts. There is a 3 dB option on the STB899 to amplify IQ. And the minimum SNR on IQ analog is 1 dB for the demodulator to be able to sync clock, to synchronize on the timing on the SR, on the same rate. Digital SNR. IQ are digitized at about 100 megahertz, 180 exactly, when you use high sample rate. When you use low sample rate, we will see later that DVB demodulator have many problems to synchronize when we go lower with SR value. It's for that reason that some set-top box doesn't go down to 1 megasymbol. You can't use it at 1 megasymbol. They cut at 1 and 5 or 2 megasymbol. So the first thing we have to do is to choose a set-top box or a PC card that can go at very low SR. And in digital processing, decoding is beginning to be very difficult when the sample rate begins to be very low. With this card, we will see that we can go down to 450 kilosample. With another card, the future card I am developing, we can go down to 250 kilosample. But we have one thing we have to do, it's to digitize at lower speed for lower symbol. So when we digitize with 8 bits, and the effective number of bits, the enob, is 7.5 bits. We can have a long discussion about that, and I think we don't have time. But this can give us the maximum SNR we can have. And the maximum SNR, theoretically, is 45 dB with this card only. And when I have studied how it works, I will see that all the dynamic plage, maximum and minimum, c'est la plage? Range, thank you. The dynamic range is not all the possibility that it can be. So, the maximum, I think, by testing and so on, I can have is 46 dB with this card. I have professional equipment, measuring equipment for DVB, and the head they have not so good, don't have so good enob. So this professional equipment can say a maximum of 25 dB. After, they just say it's up, but I don't know. The MAR. M-A-R. Modulation error ratio. It's the primary measurement, yes, of the quality textronics. I have read many books that say that when you have the MAR value, you have the maximum on information for the ability to decode or not your video. With my CFRAM analyzer, I have the MAR like that, or when I display constellation, I have the MAR here. With Tutioune, you will have the MAR with the constellation. And you will see, we can see, that when the MAR is going down, all the clouds made by the constellation are going to be bigger. and takes more place. With this mare, the constellation are very big. And we can find now that some points are outside the quadrant where they must be. But we will see it's not a problem. We have Viterbi, we have Reed-Solomon, two guys that help us to find errors and correct them. So, how mare is find? You have the target position of your point. The theoretical best value where the point, the IQ coordinate, give you a point. The point must be here. In reality, the point is here. So you have a vector for the modulation error. This is the modulation error. You have a vector. And we will calculate this vector. We will find this AVM. It's the first method to show the dispersion of the points in the quadrant. The second method is to do an average. We do an average on the cloud. And this is the mare. On Tutioune, you will see, you can ask, I want to get the value for an average for 64 kilopoint or 128 kilopoint. Or you can choose what you want to calculate, to compute this value. So, mare, I like very much this value. It's in dB. It has nothing to do with analog dB, but it's in dB. And when I give a report with my friends near my city, we now use, every time we use mare. An alternative, the AVM, error vector magnitude. Donc, same distortional measure as mare, just different manner to give the information. Now, after measuring the SN, signal noise ratio, given by the mare, we have all other information. C-bar is error rate before Viterbi correction. You have the V-bar, error rate after Viterbi correction, and the UNC, I don't know the pronunciation exactly in English, is the packet error rate, the ratio of wrong packets behind good packets, number of packets. With Tutioune, I have chosen for this time just to give the number of bits in bytes corrected by Reed-Solomon and by Viterbi during the number of milliseconds you have chosen. I think scientific value, it's sometimes difficult to understand. And the only thing we have to know, we must keep this value the lower we can. That's all. When we want to receive a signal, we need to set up the antenna direction, the power, and so on, the amplifier, to have the best value as possible, the lowest value. With other software, we can, now we have no problem. The MER is good, you have the transport stream. But even you have the transport stream without errors, you can have other kinds of errors. And these errors can be given by some software, TS Reader, but TS Reader don't give many information about errors. Or you can see the GOP, the group of picture, MPEG picture, and you can see if the first picture is very strong. You have information about the bit rate, okay, and you can find PIDs and so on. When you use Tutioune, you have a UDP button that can send directly in real time the data you are receiving to TS Reader. And I use both software at the same time. This is the most powerful software. This software gives many information, very, very important for professionals. You have all information about PCR jitters. You will see, with my modulator, I will have reset of PCR, and so on. I have many information. I can have information about underflow, overflow of the buffer. I have information about PCR reset, continuity error on PID. And I can see here all little square, the color of each square tell me what packets it is. If it is PAT, PMT, table, if it is data and so on, audio packet, video packet in blue, audio packet, and you can see them in real time. You have information about each elementary stream, video elementary stream, the audio elementary stream, and MPEG-2 transport stream, and PCA rates, PSC rates, and so on. We can spend one day only on software like that. And at the end, we can also make measure on the video. We can have at the end. We cannot do any analog measure because the video you receive is only digital information you receive. So there is nothing now we cannot use SN video that someone use in analog TV. There is no sense for that now. So the only information that we can do is about MPEG method of compression, of compress. How MPEG has been compressed. And for one tool to another, they can have big differences. But it takes time also. So, the first question is, when can I say the signal is good enough? It's the question for me. Ham radio, I want to receive a DATV station. When can I say, okay, the signal is good, I will be able to get the video, the audio without problem. Is it the RF level? No. The RF level, I can show you, I can have a high RF level with a high CNR and a very bad NR and nothing to see. If you have a power amplifier that is not linear and so on, you push it at maximum of power and you lost many things. You gain about the signal, the CNR, but you lost about the digital quality. So, the RF level, the SNR of the MER. Well, the answer is none, can tell you all, but my answer is observing the MER, and Weber is the most important thing to do. And if you use Tutioune, we will have a green LED that show you the transport stream is okay. You can decode it now. If we look at this example, this is what we can get with Tutioune. With Tutioune, you will have the video, and we will have at the bottom of the screen all that information. Firstly, the carrier lock. How the demodulator is well locked on the frequency. And the green LED to tell you it's good. The timing lock on the symbol rate. Second. The RF level. The MER, constellation, and Weber, number of bits corrected by Viterbi, number of bits corrected by Reed-Solomon. If FEC is fine, it's found automatically. And the TS statute. The TS statute say you have the transport stream. I don't know at this step if the TS stream has good packet. It's another problem. But the transport stream is here. So, in the second example, I have always minus 36 dBm. I have not changed the power. I have just changed something in my transmission to have more and more problems with the MER. I have the possibility in my DVB transmitter to add jitter in phase modulation and so on, and to give problem. So, this is the MER. 18 dBs, the constellation. Nothing to say, no error. Now, I reach 5.8 dB. These are the constellation. And you can see the Viterbi decoder is working. The Viterbi decoder is correcting some bits. And the video is always good. You don't see anything on the video at this step. Here, the MER is 4 dB only, constellation. And you will see Weber 18% error. Not only the Viterbi decoder is working, but the Reed-Solomon now is working. But TS statute is always good. You see nothing on the video. The video is very good. Nothing changed on the video. But two guys are working very, very much to correct Viterbi and Reed-Solomon. They are two friends. I know them very well now. So, and last example, MER is 2.7 dB. I have always the same level, RF level, the same CNR. In analog, with analog equipment, I see nothing different. But now, Weber is up 30%, so Reed-Solomon is overload. It's the maximum value he can correct. So, TS-STATU is bad, is red. And you can't receive the video, or each time, if the LED flash between green and red, you have some video, some freeze, some video, some freeze. Yes. The value 30% depends of the FEC you have chosen. As choosing the FEC is choosing how much bits you use to correct, to do a correction after transmission. So, to give a report, we have discussed about that. What can we do? Give RF level, MER, Weber. Bon. In Poitiers, in my city, we use the MER. And when the MER is very low, we are observing Weber in percent to see if we go near the bad value between 25 and 30%. Tutioune, the software now, yes. Tutioune, the name come from Franglish. Frankly, when I have spent 1 year in Quebec with two friends, and a friend say very often to me, you tune your rig on this frequency. Tu tunes ton rig sur la fréquence. And he use this term, tu tune. So, Tutioune is Tutioune. Now, it's the name of the software. Motivation and so on, I have talked about. The first version was only to have the possibility to make measure only. And it was Tune Demod, the first software. It was Tutioune version 0.1 to 0.9. Now I call it Tune Demod only. The second software is to display video. It's Tune Video. And when you use the two software, the two Tune Video and Tune Demod, you use Tutioune. So now there is only one software, all in one, which replaces all the two separate software. You can download them from free. So Tutioune, this was the first Tutioune. This is the frequency, to set up the frequency, to set up the sample rate, and you have a PLL with also a magic tool, which is the derotator. The derotator is a tool that can find the good frequency. It is called derotator because if I switch it off, I can show you, I have no time here, you will see the constellation turning and you will see a ring. And when you put it on, up, your constellation are fixed. And he has found the deviation. You see, 20 kilohertz, 30 kilohertz. is the real deviation. First software to make measures, second software to receive video, and now this is the software all-in-one, Tutioune all-in-one. You have just to give the SR and the frequency. That's all. The FEC is fine automatically, normal. The PID is fine automatically. PID video, PID audio. And also, if you use MPEG-2 or H.264 codec. Also, the format of the picture. You can use any kind of format, not only standard format. You can, sometimes I use a screen capture of my PC to explain some software to other OM using DRTV. So I can have any kind of format. So this is now Tutioune, and you have a button here to change in expert mode. Okay, you give the FR. There are shortcuts key to go quickly. The FEC, you don't give the FEC. You just say you can, because the STB 899 can find itself, always find itself, the FEC. Never you can tell him the FEC is this. You just can tell him you can search the FEC between this, and this. This is for the tune monitor. This is information that will be sent on the web because after, we have 2 minutes. This is the display I have spoke about. This is the expert mode. You will find again the PLL with the derotator, the symbol rate. We have an SR search. We have the EQ oscilloscope. And you can read the imbalance between E and Q, the DC offset, corrector, and so on. These are modification for the Meyer calculate. And to finish, you can record the stream if you want to send it back. You can send by UDP the stream to TS Reader, to DigiLite. When DigiLite can use UDP, you send directly, you push this button, my DigiLite software receive it, and I have a repeater. I have a free DATV repeater. And the last thing is when you press the web button, all you are measuring can be found on the web. It's free. Your icon is created automatically. You get your icon, and when an icon is green and bouncing, you can go and you will see that. You have in real time the RF level, the constellation, the MER, the Viterbi and Reed-Solomon correction. You know information about the setup. You have pictures, 1 pictures by second maximum. It's because first time for me, it's a law in France. In France, we are not allowed to send ham radio data by internet using the net. We cannot do that. So,
did you hear the news?
Yes.
There is some news. There's been a campaign.
Yes.
And it was accepted for communication, digital communication over the internet, and it's to change in the next few days. So it's it's coming very soon. So the good news is in France there will be internet linking.
Okay.
And the law is changing even as we speak.
Okay. And the last, you have here, you have all information about the evolution of these three measure RF level for 2 hours. So if there is a difference in propagation, in modification of antenna, of anything, you can see it. It's free, you can use it. The bad side, for the moment, you are obliged to use PCI cards, not USB cards, because I have not found a driver for USB cards that allow me to speak I2C with QPSK demodulator. So this is the cards you can use. And I prefer this. All software can be downloaded from my forum, Viva DRTV, for free. And future development, I always use this with the STB 899, the lower SR I can use without problems is about 450 kilosymbol. With this new, the third generation of chip, the STV0903, I have been able, for this moment, to use without problems 250 kilosymbol. And this new chip allows to do a blind scan. A blind scan, the possibility for the chip to scan all the band of a satellite, find all the frequency used, and find at the same time the SR used. So I think that with this new chip, I will be able to offer for ham radio just to give the frequency. That's all. SR will be fine, FEC will be fine, PID are fine, MPEG-2 or H.264 are found. It's all automatic. And if you want anything else, I used Tutioune to tune the free DigiLight I have built. And I was happy when I was able to reach a mere 36 dB with a DigiLight board, and I cannot have this with my professional modulator. Okay, so DigiLight, Tutioune, tune monitoring, and all we have heard today offer a new way for DATV, I think. Thank you.
So, apologies again for the eye test. There really was an awful lot of source material to edit down. And once again, if you look forward to editions of CQTV, if you're not a member, you should be joining, because there's going to be some good articles coming up. But there's a lot of very in-depth information to impart, and you've had a taste of that today. It's very kind of Jean-Pierre to come all the way across, and even his wife has come over, so very kind. Oh.
Yes.
Yeah, we have time.
Yes? Give the microphone.
With the real-time web monitoring, do you put the received program name on the received information, because it would be a bit unfortunate if you were measuring a signal being received by another station and it wasn't actually yours.
Oh, I don't know if I really understand.
It's probably quickest if you just reverse back to the web monitor. Okay, and we don't currently see the station ident, so the program.
Yes,
name.
if we you have, if in the NIT the station put his call, you will have his name here. We have seen it this morning. I receive his transmission, and up we see his call. So we have that, and also if you have put in the table your QRL locator, the distance can be written.
I just want to make one thing clear: the call sign sent every 300 milliseconds within 15 minutes.
The call sign?
The call sign is sent every 300 milliseconds.
Yes.
Which is good enough. The requirement for the legality is 15
Just
minutes.
in
Yes.
the regulatory requirement to display your call sign.
Yes.
It's happening every few milliseconds, so he's quite happy that everything's legal.
I got it. I just can say I got it.
Just one quick comment before we take another question. This is the beginning of the evolution of Tutioune, and we've discussed a number of opportunities. A true digital-to-digital repeater platform, something that we really don't see very much of at the moment. Most of our digital repeaters actually go back to video baseband and then they remodulate. So there are delays and artifacts, and we actually lose incoming program information that doesn't get transferred through. With this platform and the ability to stream out using UDP and directly into Digilight, we have the beginnings of native digital repeaters. Other possible developments are sending data, because the endpoints in this are effectively computer to computer. And for a long time, we've talked about using high-speed data, much as in the same way as the professionals use satellite links with DVB-S. We would have the same facility. So our expensive repeater-type sites on hilltops could be used to relay data. Was there another question for Jean-Pierre?
I think just one thought. Is there any possibility of developing? Is there any possibility of developing for DVB-T as well, for OFDM and CodeFM?
Perhaps. I don't know the chip. The difficulties are to find the good documentation and to find the good man to give you the good documentation. And documentation about these chips are under NDA. And so it's very difficult to have them, and you can't exchange information too much about you can find inside.
Okay, I think we ought to put our hands together again to thank Jean-Pierre for coming all the way to the side.
Thank you.
Very good. Hope you've had an interesting afternoon. That kind of brings it to a close. I bet none of you have done what I've done. I've nipped off and sung happy birthday to my 2-year-old grandson while you've been in here. So, okay, so that wraps it for today. Those of you who are in the hotel, don't forget we've got the meal. I guess we'll congregate in the bar at some point probably after 7:30, and we sit down to eat in the brasserie at 8:15. Individually, you'll pay for the meal when you're there, either book it to your room or pay on credit card then. We start again, the doors are open at 9 o'clock tomorrow morning, with the first lecture from Philip on the SDRs based around the £10 eBay dongles. That's at 9:30. So I think that's pretty much it, unless we've got anything else. Lunch, yes. We got a lady in specially to do the lunches, and she's a little bit disappointed that not everybody realised she was there. So tomorrow, please don't bring your own sandwiches. If you could patronise her, that would be really good. Otherwise, I might be eating Kit Kats and Mars bars for the rest of the week. So I think that's it. I think we're pretty much done. The place will be locked up and secured as soon as we've left. Tomorrow, those of you who are around tomorrow, we finish at 4 o'clock, and I think we would actually appreciate a hand sort of restoring the place back to where it should be at the end of the conference tomorrow. If anybody's around, that would be very useful. And with that, I wish you a good night, and see you in the bar at 7:30. Thank you very much.